All right, so for this one, we are going to talk about, does a precipitate form? So if you're in a situation where you're wanting to know whether a precipitate forms, how do we handle that? What does the problem look like? So essentially, if we have does a precipitate form, it is asking essentially, does a precipitate form when 20 mils of zero point 0.1 molar barium nitrate reacts with, let's say, 10 mils of zero point 0.1 molar sodium hydroxide. That'll be our question. The first step to take on this one, so step one, the how-to, is you've got to be able to predict if a precipitate could form. So precipitate form is the question mark, because there's going to be, do we know if that's the case? And so the question again goes back to what we did in the previous part of this chapter. Is there a reaction? And if there is a reaction for this, you will have a precipitate formed. So you start by writing that reaction. So you would have barium nitrate, which we know according to the chart is completely soluble, AQ, plus we have sodium hydroxide, completely soluble, also a strong base, so that tells us that. And then on the other side, I'm not going to put an arrow because we've got to see what's happening on the other side. We have sodium nitrate, when you look at your periodic table, look at your solubility chart, is completely soluble. And then you have barium hydroxide. And if you look at barium hydroxide on your solubility chart, it is insoluble. So you have a solid. So yes, we do have a reaction. So now I can put that arrow. I'm going to balance everything. I have 2 nitrates. Put my 2 there. So everything is balanced. So we do definitely have a precipitation reaction, or at least we know that we could have one because we have the barium hydroxide. The second part about this, so step 2 for this, and we're going to change it to a different color. So step 2 for this is now we've got to compare QSP and KSP, because we don't know if these concentration values are actually at equilibrium. We do know that we have a potential precipitation, and here's our SP, our KSP equation, where we have barium ions and hydroxide ions. And for this particular case, we've got to figure out Q versus K. And you might be going, wait a second, you just reversed the top equation. Yes. Remember, for precipitation reactions, the reaction happens first. So step 1, that reaction, precipitates form. And once that precipitates form, then it starts to equilibrate in solution. So we have our precipitation going, and now we have the equilibration happening. And that equilibration always comes from the solid on the left, or the reactant side. So 2 separate events. So now that we have that straightened out, we're going to come here and figure out what Q is. So my QSP is going to be based on my barium ion concentration. So I've got to take into consideration that it was diluted. So I have 0.1 molar times 0.020 excuse me, liters, divided by the total volume it's in. So we have 20 mils plus 10 mils. So that's going to be 30 mils. And then we're going to multiply it by my hydroxide ion concentration. And if we look at that, we're going to have 0.1 molar, and it's 0.01 liters. And then the total volume is 0.030 liters. And again, we have to know how those ions are affected. So I'm going to grab my calculator. We're going to do some math. So 0.1 times 0.02 divided by 0.03 times my 0.1 times 0.001 divided by 0.03. And we end up with 0.0022. So that's my QSP. And now we've got to compare that value with our KSP. So the KSP that we have, we're going to go to find that, we will actually go to a chart. And I sent that chart to you, so you should have that chart in your files. And when you look at that chart, you can determine, I'm going to pull it up really quickly, you should be able to determine from that chart what the solubility is of barium hydroxide. So you're going to go to the chart and see what the KSP. It's in the back of your book. You could also Google KSP of barium hydroxide. And according to my online source, it tells me that it is 2.25 times, and they'll vary because these are so small in many cases, times 10 to the negative fourth. And this value over here is 2.2 times 10 to my negative 3. So it is still greater than my KSP. So because my Q is greater than, if it's equal to or greater than my KSP, that tells me that a precipitate is formed. So the answer to our question is yes, a precipitate formed. One, we found out that it could, and the second one, we actually determined numerically the value of QSP, and we compared it to KSP. And if it's equal to or greater than, we have a precipitate formed. And these are the steps essentially that you'll follow to be able to determine that.